Well, hello and welcome back. I'm Ruben Gamboa, and this is week 3 of Visualization Basics game programming. So again, I'm doing this presentation with a whole lot of help, what I call team game programming. And to this week, what we're going to focus on is a couple of key principles that you need to know in order to build the game of Pac-Man, actually, so that you can think of that as the ultimate goal of the week. But also the same techniques are very useful for a lot of different projects. And so we'll also show you some simulations that make use of them as well. So the first thing that we're going to focus on in order to be able to build any game is to display the score. So we have this so far. We have a game, and every game is made up of these components. You have avatars, which are things that the user can control, like Frogger or Pac-Man. You have AIs, and these are things that the system builds. These are actual active agents. You know, they can move, they can have different actions that they take. Trucks, turtles, ghosts, all of those things in any game you'll find. You might also find some scenery. I think of this as active in the sense that they don't necessarily move, but they have some behavior. So like power pellets in Pac-Man, where if you eat one of those, then all of a sudden Pac-Man becomes Super Pac-Man and the ghosts start running away. It's just sitting there, right? But it's actually active. And on the other hand, there is passive stuff, terrain, which is really just the background. You know, roads, rivers, fields, whatever. So we built a game that has all of this. We still can't keep score. Now, let's try to do that, okay? So what we want to do is the score will change due to some action of the avatar. The avatar grabs a pile of gold. The avatar eats a pellet. The avatar eats a ghost. Okay, whatever it is, that should change the score. Now that can happen anywhere on the screen. That's not where you want to display the score. The score needs to be displayed someplace else. So how can we actually make that happen? We need to, in a sense, send a message to some object that's sitting someplace in a different place on the screen. Up to this point, the only thing we've seen is how an agent can change or affect one of the agents that's right around it. Okay, so this is a huge step. Now there are two commands that help us with that in AgentSheets. The first one is called broadcast, and in the case of broadcast, what we have is the ability to send all agents of the same type, for example, all ghosts, or even all power pellets, some kind of a message, okay? And each agent then has a little set of rules that says, if I ever get a message that says X, then here are the rules that should happen, okay? So, so that's how this works. We'll set up a group of rules which is different than the one we've been working on. And that group of rules is called a method in AgentSheets. And whenever the object, or I should say the agent, receives that message, then it will go ahead and run the rules in that method. I should point out that broadcast is useful not only because it makes agents everywhere in the screen do something. It's actually quite useful because it makes them do something right now. It doesn't wait. The agents actually do the actions right now, and that's actually a powerful way to synchronize different agents. We kind of alluded to this earlier when we were talking about the problems that maybe some of the agents can interfere with each other as they're progressing, and we said there will be times where we want them to do things in lockstep. Broadcast is what that's for. Okay. Now there's another command that's very useful, and it's called make. Make is similar to broadcast in the sense that it sends a message to somebody. It's like poking them and saying, go do this. The difference is that make acts locally. So make simply tells the person next to you, do something, okay? Whereas broadcast would tell all people to do something, okay? Okay, now we want the score to show up in only one place. If you want it to show up in two places, then that's okay. You have to have two objects or two agents of that type, the score keeping type, someplace, okay? But what we'll do is we'll keep only one agent of this type. We'll hide it in a corner so that the score is shown in that corner, okay? And whenever it receives the message, it will increment the score. That's the idea, okay? But we have to answer the question, how does it respond to the message? And how does it actually keep the score? So let's talk about this. What we'll end up doing, and I'll show you this in a demo, is to create a new method. And remember, a method is just a bunch of rules that are going to execute whenever that agent gets that message, okay? So the method might be called increment, okay? And whenever the score agent gets the increment message, then it will go ahead and increment the score by 1. Okay? What we've been doing so far is to put everything inside a special method called while running, and that just keeps getting called whenever the agent is alive. Okay, so that's essentially it. Okay, here are some of the other triggers. Okay, that actually could make a message execute while running. Just always do it. While creating a new agent, that happens at the very beginning. Whenever you build an agent and you put it somewhere in your worksheet, at that point, if you have a method called when creating a new agent, it will get called. Okay. There's also a number of tools, and we've seen those in the AgentSheets in the worksheet off to the left side, and you might have like an arrow or a hammer or a hand. And what happens is that the user, while the game is running, can actually click on those and then prod one of the agents on the screen. And then the agent will respond, oh, you hit me with a hammer, I should do such and such. Oh, you hit me with an arrow, I should do such and such. Okay. You can also just simply mouse click on it, and that will do it. The one that we're interested in right now is on method. And the method is just a name that you can create. So for example, you can call it increment, decrement, reset. That would set the score to 0. Or anything that you want. Okay. That's what we'll use, on method. Okay. So let's build increment, okay? We're going to increment the score, but how do you display? Ideally, we could say, put a text right here, and the text that I want you to put is 12, because that's the current score. Unfortunately, you can't do that. The only thing you can put on a worksheet is agents. So we'll have to put in agents that somehow have the score in them, okay? Now, we can't have an agent for 12 and 13 and 14 and 15 and so on. So instead what we'll do is we'll have 10 different agents. Oh, I'm sorry. One agent, but with 10 different depictions, okay? Those are the actual images that are shown. It's the same agent. It just has different depictions. And I like to think of this agent as being called digits, okay? And he has 10 depictions. One that looks like a 0, one that looks like a 1, one that looks like a 2, and so on. So when he starts out, the agent has a 0 depiction. When we tell it to increment, then it changes his depiction to 1. When we tell it to increment again, it changes his depiction to 2, and so on. And that way we're counting. Okay? So here's the plan. We're going to put the agents kind of in a row, and it's going to look like S, which is our fantastic score agent. That's the only one that actually responds to the global increment method. Okay? So when somebody broadcasts increment, it is the score agent that will receive that. Okay? And what the score does is it will make, notice the difference, it's not broadcast, it's make, because it's going to make the digit directly to his left to increment. Okay? The digit will then go, oh, okay, if I happen to be a 0, I become a 1, if I'm a 1, I become a 2, and so on. And finally, if I happen to be a 9, then I have to be careful. My depiction becomes a 0, and I'm going to make the digit to my left increment, right? It's a special case. If you have all digits, surely we'll never run out of digits, okay? But in the case where there is no digit to the left, then what should it do? It's not that difficult, actually. We've already seen how to create an agent, so we'll just make a new agent, which happens to be a digit, and then tell it to increment. Before I show you how this works in AgentSheets, I want to make a couple of connections to math and computer science. What we've just talked about is what's called an algorithm. And this algorithm essentially adds 1 to a number. And to be honest, it is exactly the algorithm that we teach kids when we tell them to add. Okay? So yeah, you take the 1 and you add it to the leftmost digit, or the ones digit. If there's no carry, then we're finished. If there's a carry, then we set it to 0, and we carry the 1 by adding a 1 to the next digit, and so on, right? Actually, it's really easy to do this in binary. It's not that bad to do in ternary. It's really a pain to do in decimal. It's not that it's any more complicated. It's just that in decimal you have 10 cases to worry about. In binary there would be only 2. So it's actually easier to implement in binary. But again, that's a connection to mathematics because that is change of basis, which is one of the things that you expect kids to be able to do. Okay. We're not doing this here, but you could actually do the same thing with addition. And so you could have an agent like look below it and say, okay, so if I need to add and my current depiction is a 3 and the agent that's below me, its current depiction is a 4, then that should become a 7. And again, you can worry about the carry and so on, but we're not going to deal with that, okay? But there is one really important lesson here that shouldn't get past us and definitely shouldn't get past the students. And that is that simple things like digits can do amazing, complicated behavior by following simple rules, okay? There's a deep lesson that we're right here and we can show. There's kind of another subtle lesson that we can make, and that is the difference between what's called a numeral, which is a representation of a number, and a number, which is actually a notion of counting. So the numeral might be 1, 2. The number is 12, okay? In computer science, we often talk about the difference between syntax and semantics. A syntax describes how something looks. Semantics is what it means. And all of these commands that we've been talking about, methods, actions like move, all of them have a syntax. What does it look like? Move to the right. And a semantics, what does it do? Oh, the agent changes position. Okay. Right now what we're doing is we are displaying a score as a numeral, but we aren't really keeping score, okay? That would be the number. So if you actually stopped the agent and said, so what's the score right now? It would say, I have no idea. If you can read the score at the bottom, because we can see the numeral, which is to know what the actual score is. Okay. If we wanted to keep score, what we could do is do something global, and that's called a simulation property. That's the name of it, okay? The word simulation there is really the same thing as game. So we have a global property, which we might as well call score, and it could be anything we want it to be. It could be a score, it could be the number of lives left in a game, how many enemies are still alive, the time, all sorts of things, okay? You know, this is just any kind of global characteristic that you're interested in keeping track of. If you want to set that, you can actually just refer to a simulation property with the syntax at, the at sign, followed by the name of the property. So for example, at score, and you can say set at score to be equal to at score plus 1. And that would actually change the score. It would increment it, okay? You could also plot the value of that property over time. So you could see a graph that shows the score going up as the game progresses.